Okay, this is a brief description of Newton's laws. The first law, an object at rest stays at rest, and an object in motion stays in motion at a constant speed in a straight line unless acted on by an unbalanced force. So if we look at an example, we have an object here, it's at rest, and I can place a force on it, but the object's not going to move. I have not placed a force on it that is greater than the friction that is holding it there. So when I apply a force that's greater, now the forces are unbalanced, so the object will move or accelerate. And the opposite is true here. The friction force is greater, so then it causes it to negatively accelerate. The same is true if I have an object that's moving. So in this situation right here, let's talk about this car. The person is in the car and they are moving forward. The car gets the unbalanced force from the wall. The person does not receive an unbalanced force, so they continue moving. That's inertia. He doesn't want to change his motion. He was moving forward, so he continues to move forward at a constant speed in a straight line unless an unbalanced force acts on him. And in this case, it's gravity. If gravity didn't act on him, he would continue to just fly through the air at a constant speed in a straight line. Law 2. Let's take a look at Law 2. Law 2 says the acceleration of an object depends on the mass of the object and how much force is applied. So, let's go over here. Let's change this to 100 kilograms. Now, if I place a force on it, how much force I need depends on the mass. Okay? Now, let's take these away and put the fridge. I have more mass, so I'm going to need more force to make it accelerate. And this one might not accelerate with that friction. See, this has so much friction, I don't have a force that's going to be big enough to be able to do it. So I have to take some friction away. Let's increase. There we go. Now, I have enough force to make the bigger mass accelerate. Now, let's see. So that takes like 200 and something newtons to make it go. The more force I have, the more that it goes. Now let's show it with like the smallest. Now I only need like 40 something newtons to make it accelerate. And if I push with more force, look at how fast she accelerates. So that's Newton's second law. They always talk about objects that are different sizes or them applying different forces. It's an easy giveaway. The third law. The third law says one object exerts a force onto a second object. The second object will exert an equal force in the opposite direction back onto the first. So, let's look at this. I have a cannon with a cannonball. When the cannon pushes on the ball also pushes back on the cannon, so that's why the cannon would roll back after it fires. which they don't show it rolling back, but it's right here. So the cannon pushes on the ball, and the ball pushes back on the cannon with the same amount of force in the opposite direction. It's law 3. Here's another example. The swimmer pushes with her feet on the wall to the right. The wall pushes back on her feet to the left, and then she accelerates off. That's the third law. And then let's talk about this seatbelt. Because yes, this is the first law, but we know that all of us were going to wear our seatbelts. So, well, hopefully anyway, when the person goes to fly forward, they are going to push on their seatbelt. Let's look at this. So they're going to hit the wall and fly forward. When they fly forward, they're going to push on their seatbelt in this direction, and the seatbelt is going to push back in the opposite direction and bring them back to the seat. So that's a quick overview of Newton's 3 laws of motion.